Hi guys, today we're going to be looking at a question on boiling points and intermolecular forces. The boiling points of 5 organic molecules, P, Q, R, S, and T are studied. Question 3.1. Define the term boiling point. Boiling point is the temperature at which the vapor pressure of a substance equals the atmospheric pressure. The boiling points of compounds Q, R, and S are compared. Question 3.2. Give a reason why this is a fair comparison. So, we are comparing these three. So, this is a fair comparison because, well, firstly, they are all alkanes. So, they are all part of the same homologous series. And they all have the same number of carbon atoms. The boiling points of Q, R, and S are given below, not necessarily in the correct order. Question 3.3. Which one of the three boiling points is most likely the boiling point of compound R? Explain your answer. So, compound R, as we can see, is 3-methylpentane. Compound R is less branched than compound Q, as it only has one side chain, whereas compound Q has two side chains. But it is more branched than compound X, which has an S, which has no side chains. Therefore, it is most likely that compound R has a boiling point that is between the two of them, making it 55 degrees Celsius. So we can say 55 degrees Celsius. We can also say that compound R has a longer chain length than compound Q, as it is pentane, whereas Q is butane. But it has a shorter chain length than S. Question 3.4. A mixture of equal amounts of P and T is placed in a flask and heated to a temperature below their boiling points. Assume that no reaction or condensation takes place. The vapor produced is collected in a syringe. Question 3.4.1. Which compound, P or T, will be present in a greater amount in the syringe? So, compound P is pentanol, whereas compound T is pentan 1-ol. And since the vapor is being collected in the syringe, and it is being heated to a temperature below their boiling points, we want to know whichever one has the lowest vapor pressure will be most likely to be present in the syringe. So, lowest vapor pressure means highest boiling point. So since we have a temperature that is below their boiling points, we want the one that has the lowest boiling point, as that's the one that's most likely to produce the most vapor. And between pentanol and pentan 1-ol, pentanol has weaker intermolecular forces. Therefore, it has a lower boiling point. So compound P will be present in a greater amount in the syringe. Question 3.4.2. Explain the answer to question 3.4.1 by referring to the types and strengths of intermolecular forces. So as we have said, in compound P, it is an aldehyde, and there are only dipole forces and London forces. Whereas in compound T, which is pentan 1-ol, there is also hydrogen bonding. This means that the intermolecular forces in compound P are a lot weaker than the intermolecular forces in compound T. So less energy is needed to overcome the intermolecular forces in compound P, causing it to produce vapor at a much lower boiling point. And that's all for this video. Thank you.